Good morning. Today we're going to discuss about ionic equilibrium, and when we are talking about equilibrium, then actually there are mainly three types of equilibrium in chemistry. So first, actually, if you see that we know this is your equilibrium, and always remember that equilibrium, when we are talking about equilibrium, that means it's always involved with a reversible process. Okay, so equilibrium will be associated with reversible process. So please remember this point. Okay, if a process is not a reversible process, then we cannot use the terms equilibrium, or we cannot use the concept of equilibrium in a one-dimensional or one-directional reaction. Okay, so mainly equilibriums are three types. The first one is your chemical equilibrium, second one is your phase equilibrium, and here last one is your ionic equilibrium. So we're going to mainly discuss about the ionic equilibrium in this class. When we are talking about chemical equilibrium, actually chemical equilibrium is the is involved dissociation of chemical compounds, okay, both in solid and gaseous form. And in phase equilibrium, actually equilibrium exists in between two phases. That means, let's suppose one solid state and one liquid state. Okay, so if in between interface there will be some equilibrium between this solid and excuse me, liquid state. Okay, so that is your phase equilibrium. And in the ionic equilibrium, actually we will going to talk about the equilibrium which will going to be exist in between some molecules, or some molecules, or some electrolyte with your ions of that molecules. Okay, so and the process should be reversible process. Again, when we are talking about this reversible process, that means the process, there will be some forward directions, and also that product will also going to combine to give back that reactants. That means your backward reactions. Okay, so that means the process is reversible. Okay, so and most importantly, you have to know these things, that this reversible process is mainly observed in weak electrolytes. That means we are going here we are talking about ionic equilibrium. So ionic equilibrium means mainly electrolytes. Okay, electrolytes and some compound which can form ions in their aqueous solution. Okay, so mainly the weak electrolytes, like weak acids, like weak acids, weak bases, or sparingly soluble salts, they will going to show this type of equilibrium, because they will not going to dissociate it completely into their ions. Okay, thus ionic equilibrium can be applied to dissociation of weak acids like acetic acid. Okay, and dissociation of weak bases like ammonium hydroxide, dissociation of sparingly soluble salt like silver chloride, like that. Okay, so here the example will be like CH3 COOH. Okay, this is acetic acid for weak acids. Okay, and dissociation of weak bases, that means ammonium hydroxide, example, in aqueous solution, but these all are in aqueous solution. Okay, that means in water. Okay, and dissociation of sparingly soluble salt, example you can say silver chloride in water. And dissociation of water, so the water can also dissociate into ions, is positive and O is negative. Okay, so also this process is also involving what, this process involve ions. So we can use that ionic equilibrium terms also in this dissociation of water, also hydrolytic dissociation of some salts. Okay, so actually we in this video we're going to mainly discuss about in detail about these topics, and also some important topics like buffer solutions and their buffer actions, how buffer solution work, and like that. Okay, and mainly now, since we are mainly focusing on the acid and bases, weak acid and bases, so what we have to know, we have to know about acid, what is acid or what is base. We have to know the definition of the acid and bases. Okay, and what is weak acid and what is weak basis, or what are weak bases. Okay, so actually that weak term is coming from the strength now, how fast they will going to dissociate it into their ions. Okay, so to know about these terms, acid and bases, that actually the weak acid and weak bases, we need to know about the acid and bases. So let us now discuss about uh, some basic concept of acid and bases. Okay, first, then we're going to go in details about the ionic equilibrium for that acids, and that means weak acids and weak bases. Okay, so coming to the acid base bases, the concept of acid bases, actually many, there are different concepts are here for acid bases. Okay, so first, actually the first concept is coming from Arrhenius. Okay, and according to Arrhenius concept, an acid is a substance that dissociated to give hydrogen ion. Okay, H positive ions, that means when dissolved in water, when an acid will going to dissolve in water, then that acid will going to give H positive ion, that means hydrogen ions. And this is the concept of Arrhenius. That means according to Arrhenius concept, we can say that an acid is a substance that is dissociated to give hydrogen ions when dissolved in water. Okay, so this is the Arrhenius concept. But here if you notice one thing, here we write here aqueous, H positive aqueous, CH3 COOH, acetate ion, aqueous. Why we write aqueous? The the symbol aqueous, actually this aqueous indicates that the ions are actually hydrated. Okay, the meaning of it is that it associated with one or more molecules of water. Okay, so that means like that, you see here, because we are preparing that solution of acid, weak acids, we just add water. So here water will be there. Okay, water will be there, and here the acetic acid will be pour in that water solution. Okay, little amount of acetic acid. So when the acetic acid is added to that water, then what will going to happen, that acetic acid will going to form H positive ion plus CH3 COO negative ion. Okay, CH3, okay, CH3 COO negative ion. But here H positive is has positive ions, that means it will going to carry some charge, positive charges. Okay, so again we know that water molecule is like this one, two hydrogen, one oxygen atom bonded with each other. So here because of the electronegativity difference of oxygen and hydrogen, I think you know about electronegativity, that means the tendency to attract the electron towards themselves. Okay, in when it will going to form a covalent bond, then the sharing of electron, there are electron will going to share between this one and this one. Okay, let's suppose oxygen and hydrogen, two electron, like one electron will come from oxygen, one electron will come from hydrogen, and they will going to share this electron in between them. But oxygen electronegativity is higher than hydrogen, so this electron pair will more towards the oxygen, so that means it will be del negative. Del means a small, okay, del represents small negative, and this is del positive. So similarly this one. Okay, so here since hydrogen will be present there, hydrogen ion from that acetic acid, okay, acetic from that acetic acid, hydrogen H positive will be formed in that solution. And since this H positive carries some H positive ions, that means this will going to have some attraction between, there will be some attraction between this positive charge and this partial negative charge. Okay, so that means this hydrogen positive will be surrounded by many many water molecules spherically. That means many water molecule will be there, which will going to form a sphere. Okay, and it will going to surround this H positive ion. Okay, cover this H positive ion. So, and this sphere is actually known as hydrated. That means this all this process is known as hydration. Okay, solvation actually, because this is water is used, so hydration. Okay, so and this all the process is represented by this aqueous. So this aqueous is actually used for this region. Okay, actually you can also write this reaction like this also, CH3 plus water. So here water, then it will going to give you H2O positive. Okay, actually this is aqueous. H positive aqueous means H2O positive, same thing. Okay, plus CH3 COO negative aqueous. Again here also aqueous, because here H positive ion will be there, no? Is del H positive, is del positive will be there. Okay, so this del is del positive will going to form an it going to attract this negative CH3. Let's suppose here CH3 COO negative, and here is del positive O negative is del positive, so they will going to form a sphere. Okay, is positive like that. Okay, is del positive, so this is also represented by this aqueous. Understand? So that means according to Arrhenius concept, we can say that an acid is a substance which can form H positive ion in their aqueous solution. So this is the concept. Okay. So now coming to the second concept, which is given by Bronsted and Lowry, and they actually generalized the concept. Um, this is actually more general definitions of acid and bases. And according to them, an acid is a substance which can donate proton to any other substance. Okay, and a base is a substance which can accept that proton from any other substances. But according to Arrhenius, it was what? An acid is a substance which can donate proton only in aqueous medium. Okay, so according to Arrhenius theory, that means Arrhenius concept, it is on the solvent is only aqueous, that means water. But here the the acid has the capacity to donate H positive, that means proton, to any other substance, and the base has the capacity to accept any proton from any other substance. Okay, here that means here let's suppose an acid. Okay, this is your acid, and it can that means according to our Bronsted and Lowry concept or definitions, then acid can donate proton. So let's suppose it will going to donate proton. Okay, so the actually the residual part, that means this part will going to act as a base. Why? Because that part will going to have some tendency to accept this proton to form that acid bake. Okay, so that means this is reversible process now, because this will again going to take that is positive that means proton and get back to the acid. So that means this is your acid, and this is actually known as conjugated base for that acid. So this conjugated acid and base concept is coming from actually Bronsted and Lowry concept. Okay, so let us suppose now we are going to discuss about conjugated acids and bases. Okay, acids and bases. Now let us understand the concept of conjugated acid and base by using an example. Okay, so here the dissociation of a weak acid, that is acetic acid, in aqueous solution. Okay, that means water. So here it is actually evident that this will going to act as an acid, that means CH3COOH, because you see here, if you notice this reaction carefully, then you observe that this CH3COOH will going to donate a proton, H positive ion, to the water molecule to form that hydronium ion. So actually this is, you see, this CH3, the structure will be like this. Okay, and this is the water, actually H2O. Okay, so here this acetic acid in water, actually this bond will going to break, and the electron will come here, and this is become positive and this is become negative. Okay, so that means here this will become positive and this is become negative. Okay, this part. So and here this there will be a lone pair, and this lone pair is going to be donated from this oxygen atom in water to that is positive, and then they will going to form from this one H2O positive, that means hydronium ions, and this will going to give you what? This part is actually the remaining part will be CH3 COO negative. So that means this substance has the capacity of donating that proton, okay, to that the substance, the other substance. So it will going to act as a what? Acid. So what we can write here? We can write here that this will be your acid, okay. So, and here if you notice this one, that means this substance has what? This substance has the capacity to accept that proton. That means this will going to act as a what? Base, okay. This will going to act as a base, understand? So, and this is actually your solvent also. And here so here this acid will going to give the proton to that substance, and it will act as an acid, and the remaining part of this acid will be your act as a base according to the Bronsted concept, okay. And here this is the base now, and this will going to accept, because this, why this is base? Because water will going to accept that S positive ion. So, and its conjugated part will be what? Your acid, okay. Why is it? Because if you notice this right hand side also, then you can able to understand that this CH3 COO negative act as a base, because this part has a tendency to accept electron from the other substance, from this hydronium ion, to get this one CH3 COO. That means this CH3 COO negative, this negative will going to has the capacity to accept what? S positive ion from this one. So this will going to be act as a base, okay. So this is your base, and this will again going to actually this has actually capacity to donate the S positive ion to that base. So this will be act as a acid, okay. So that means, and here because these bases are actually coming from here now, so it will be, this base is actually conjugated base of this acid, and this acid is a conjugated acid of this base, okay. So this pair are known as conjugated acid and base pair. Actually there are two pairs are there, a conjugated acid and base. So here this one and this one, okay, this one and this one is your conjugated acid and base pair, and here this one and this one is your another conjugated acid and base pair, okay. Hope you understand this point. So actually the conjugated acid basis concept is coming from the Bronsted-Lowry concept, and this is important because why? Because by, if you let's suppose you know the strength of this base, then you can, by knowing the strength of this base, you can know the strength of this acid, that means the conjugated acids. Actually the the definition of the conjugated acid and base pairs is given in your books, and according to that book, actually the definition is the here the pair of substance which can be formed from one another by the gain or loss of a protons are known as conjugated acid base pair, okay. Simple, because here see, this is the substance according to the definitions, a pair of substance, that means this pair of substance. So these are, let's suppose this is one pair, okay. This pair of substance which can be formed from one another by gain or loss of a proton. So if a gaining of proton will be, if this base will gain a proton, then it will going to form this acid now. So by gaining or losing of a S positive ion are known as conjugated acid and base. So they are related by what? They are related by just this H positive ion. If there's H positive ion removed from this acid, then it will going to form that conjugated base of this acid, okay. If this base will going to form a bond with that H positive ion, then it will going to form that conjugated acid. Similarly this one also, if this water will going to accept H positive ion, then it will going to form their conjugated acid, and if that acid will going to donate H positive ion, then they will going to form their conjugated base, okay. Understand? So this base is conjugated base of this acid, or this acid is conjugated acid of this base. You can say anything like that. Okay, I hope you understand this concept, and Now we're going to mainly discuss about the outcome of these discussions. Okay, so we have some output from this Bronsted and Lowry concept of acid and bases. Mainly there are three outputs are there for this concept. The first concept is, here we have we actually understand about the acid and bases, and according to that Bronsted and Lowry concept, we know that then acid, let's suppose this is a substance, and acid is a substance which can donate what, a proton to to another substance. Okay, and a base is a substance which can accept that substance. But the thing is that the nature of this substance, whether this will going to act as an acid or base, is depends upon the other substance. That means the substance in which it is added. Okay, understand? So let's suppose this is your acid. I don't know whether this is acid or base, but suppose this will going to let's suppose this water can accept H positive ion from that substance. Okay, SA, then SA will be your what, acid, because that other substance will going to take that or accept that H positive ion, okay, to form that H2O positive. Understand? Inactive. So if the substance, let's suppose this substance cannot accept H positive ion from SA, then SA will not be act as an acid. Understand? So this is the concept. That means you can also understand this concept by taking one example. For example, acetic acid or hydrogen chloride. Let's suppose acetic acid solution. You add an acetic acid solution, CH3COOH plus, in water. Then no doubt you will going to get CH3COO negative plus H3O positive. That means it will going to act as an acid, because it can donate proton to that other substance, or that other substance can accept proton from that acid. Okay, so it will going to an acid. Okay, but the same thing, let's suppose CH3COOH, if you add in a benzene, then it will not going to act as an acid, because in this case the benzene does not have the capacity to accept accept proton from that means H positive from this acid or this CH3COOH. So that means CH3COOH will not going to act as an acid in benzene medium. Understand? So this is the first outcome from this Bronsted and Lowry concept. And second outcome is also very interesting. Okay, if you H positive in aqueous solution is not exist actually. Okay, actually we write in H positive in aqueous solution like H positive aqueous, for just to write, this is for convention. Actually this is conventionally we write this one, but actually this H positive in water is in H2O positive form, hydrated form. That means this is a hydronium ion, and this is known as what, hydronium ion. Okay, hydronium ion, because it is similar to that ammonium ion, NH4 positive, so it is known as hydronium ion. Okay, and the third one is your not only molecules, also the ions can show the acidic and basic nature. Let's suppose this one is CH3COO negative. This is going to act as a what, basic. Why? Because they have the capacity to accept a proton, so it will going to act as a basic. Okay, understand? So not only is that means molecules have the tendency to gain or accept or donating proton, but ions have also the capacity to show the acidic or basic nature. Okay, this is the third point. So hope you understand the outcome of this Bronsted and Lowry concept. It means there are mainly three concepts are there. First concept is your the acid the acidity or the basicity or is not only depends upon that particular substance, it also depends upon the other substance which is which is added to that with that substance. Okay, second is your that H positive ion actually exists as hydronium ion, and third one is your that ions can also show the acidic or basic nature. Okay, now coming to the next concept, which is your amphi protic, so amphiprotic or amphoteric substances. That means actually the amphoteric or amphiprotic substance are those substances which has the capacity to show the both nature, that means acidic and basic nature. Okay, so that means that substances can show the acid as well as the base nature. Okay, so let us discuss or let us understand this topic by using example. Okay, so here let's suppose this is your CH3 COOH. Okay, so suppose we add the acetic acid in water. Okay, water, so it will going to give you what? It will going to give you H3O positive plus your CH3 COO negative. Understand? Here, since this substance can donate H positive ion to that other substance, that means this will going to act as a what? Acid. Okay, and here this will going to act as a what? Base, because this can accept that proton from this acid, so it will going to act as a base. Again, if you consider here, then this will going to have the tendency to accept proton, then it will going to act as a base. Hence we know that these two are related by that H positive ion. That means if this both base will going to accept an H positive ion, then it will going to give that acid. So these are what? Conjugated acid and base. So we can write here acid 1 base 1. So that means acid 1 and base 1 is the one conjugated acid and base pair. Okay, so similarly these two are also related by H positive ion. So that means this is your acid 2 and this is base 2. Okay, so here that means this water will going to act as a what? Base. Okay, so this in this example water can act as a base. So this is the point. Okay, the second, let's suppose, so this one is your base. Okay, so again let's consider one more example, ammonia. Okay, ammonia plus water. So in this example here the ammonium will going to NH4 positive. Okay, ammonium, and it will going to give you actually OH negative. That means this substance, okay, this substance has the tendency to actually accept electron from, not electron, base positive from the water. So it will going to act as a what? Base. Okay, and by accepting that proton it will going to become NH4 positive. That means this is your what? Acid. Okay, so it will be your 1 1 because they are related by H positive ion and they are your conjugated base and acid. That means conjugated acid and base. But here water will going to act as a what? Acid, because they can donate proton to that base 1. So it will be act as an acid and this will be your base. Okay, because this one and this one are related by H positive ion. Okay, so this is, that means what we observed that in these two example water can be act as an acid as well as base. So water will be your amphoteric or amphiprotic substances. Okay, so in the next class we're going to discuss about the relative strength of acid and base pairs, and from the relative strength of acid and base pair we have the idea about the weak acid and weak bases. Okay, and by knowing that strength, that means the weak acid or weak base, that means whether a acid will going to act as an act as a weak acid or weak base, we will going to apply the ionic equilibrium concept. If the acid will going to act as an weak acid, or if the base will going to act as an weak base, then we can easily apply the equilibrium concept. Okay, actually we're going to actually extend the equilibrium concept, chemical equilibrium concept in ionic reactions.